So far we mentioned libraries, crates, packages, modules, artifacts, and to understand these terms we need to look at the Rust module system. So Rust has a number of features that allow you to manage your code's organization, including which details are exposed, which details are private, and what names are in each scope of your programs. And these features sometimes collectively referred to as the module system. Module system will include packages, and packages are cargo feature that lets you build, test, and share crates. We have crates, and crates are tree of modules that produces a library or an executable. We have modules, and then we have this keyword use that lets you control the organization, scope, and privacy of paths. And we have paths, that's a way of naming an item, such as a struct, a function, or a module. Let's first look at crates and modules. So Rust has two distinct terms that relate to the module system, which is crate and module. So a crate is a synonymous with a library or a package in other languages. And when we use cargo, and cargo is the name of Rust package manage tool, you ship your crates to others with cargo. Crates can produce an executable or a library depending on the project. Each crate has an implicit root module that contains the code for that crate. And you can define then a tree of submodules under that root modules. And modules allow you to partition your code within the crate itself. In other words, a crate is the smallest amount of code that Rust compiler considers at a time. A crate can come in one or two forms, a binary crate or a library crate. Binary crates are programs you can compile to an executable that you can run, such as a command line program or a server, for example. Each must have a function called main that defines what happens when this executable runs. Library crates, they don't have a main function and they don't compile to an executable. Instead, they define functionality intended to be shared with multiple projects. Still looking at the Rust documentation, we find information about the Rust module system that is used to organize code into logical units called modules, which provide isolated namespace within the code. The source code for a given crate may be subdivided into one or more separate modules. And this is usually done to organize the code into areas of related functionality or to control the visible scope that can be public or private of symbols within the source, like structs, functions, and so on. We've seen before that when you use cargo, that it exists a cargo toml file, which is primarily concerned with the package it defines, its crates, and the packages of the crates of which they depend. A package is a collection of source files and a cargo toml manifest files which describes the package. A package has a name and a version which is used for specifying dependencies between packages. A package contains multiple targets, each of which is a crate. The cargo toml file describes the type of the crate, like we mentioned before, if it is a binary or a library within the package, along with some metadata about each one. When we look at our example of playing back a WAV file, we see that the first line we have this keyword use, and we have some words separated by double columns. We will talk about the keyword use later on, but first let's talk about this structure here, which is a path. So path is a sequence of one or more path segments logically separated by a namespace qualifier, the double column. If a path consists of only one segment, it refers to either an item or a variable in a local control scope. If a path has multiple segments, it always refers to an item. We can have simple paths, can use paths in expressions, and we will talk more about paths later on. For now, we scratch the surface of packages, crates, modules, paths, and we will go further in depth into these concepts when we use Rust and we do more examples. For now, I just wanted to give an overview of this so-called module system. So when we mention packages, crates, modules, paths, we already understand their meaning. In the next tutorials, we're going to start going line by line into our example. We'll take a look at the use keyword. We'll take a look at the fn keyword, and here we see function, and this is the main function which we also talked about. We mentioned the main function, which is very important when we talk about binary crates. There are programs that you can compile, and each must have a function called main that defines what happens when the executable runs. We will go in depth into main, to functions, to paths, along this series of tutorials. For now, what's important to understand is this concept of packages and crates, modules, the module system. We can have crates that are libraries, we can have crates that are binary executables, we have namespaces that we'll talk later, we have paths, we have things that can be public or private. So all of this we need to understand. We are using Rust, and these are very similar to many different languages, perhaps different names, but the concepts are more or less the same depending on the type of language we are using. For now, I say goodbye, and in the next tutorial we will look at the keyword use, more about this first line of our example, which is used standard IO buff reader. See, the buff reader is also used here. We append something, a sink, and we kind of touch the surface of sinks when we talked about this broad IO rate we use to play back a WAV file. So, see you next time.